Welcome. Please make yourself at home. I've been expecting you, and I am really excited to finally see you here.
You see, I've got some very interesting information to share with you. You may recall from the second video in this series that chemicals are broadly classified as being organic or inorganic. Well, in today's video, we'll be exploring organic chemicals which contain carbon and are derived from living or previously living organisms. If you're like most people, you're probably baffled by the long, complicated chemical names of ingredients in commonly used products. Well, today, we'll try to unpack some of those confusing chemical names. First, we'll review some basic naming conventions used in organic chemistry. Next, we'll examine some common subgroups of molecules that give the overall chemical its functionality. These molecular subgroups are known as functional groups. And finally, we'll take a look at some common chemical additives that contain those functional groups. So if you're ready, then let's get started. So, organic molecules typically consist of carbon atoms bonded together in a chain, or ring, or combinations of both, with functional groups attached at one or more positions along the molecule. Two key characteristics of organic molecules is the number of carbon atoms they contain, and the number of covalent bonds there are between adjacent carbon atoms. If all bonds between adjacent carbon atoms are single bonds, then the compound is generally referred to as an alkane. If one or more of the bonds are double bonds, then the molecule is called an alkene. If any adjacent carbon atoms are connected by triple bonds, then the molecule is classified as an alkyne. The names of straight-chain molecules in each classification follows a common convention based on how many carbon atoms are in the chain. So the simplest alkane contains one carbon atom bonded to 4 hydrogen atoms. It's called methane. You may know it as natural gas. The next alkane with 2 carbons is called ethane. The next sequential alkanes containing 3, 4, 5, and 6 carbons are propane, butane, pentane, and hexane respectively. These carbon chain molecules aren't limited to a maximum of 6 carbons. For example, the alkane containing 8 single bonded carbons is called octane. Alkenes use similar prefixes, but their names end with the ending of their group name. So the alkenes are ethylene, propylene, butene, pentene, and hexene. Notice there is no single carbon alkene, namely, methane, because a minimum of 2 carbons are required for a double bond to exist between them. Alkynes follow a similar naming pattern as shown here. Okay, so now that we've seen how fundamental organic molecules are classified and named, let's explore some of the more common functional groups that give organic molecules their functional properties. You may recall from the previous video that hydroxyl groups are one of the more frequently occurring functional groups in organic molecules. It consists of an oxygen atom bonded to a hydrogen atom. Hydroxyl groups are present in ethanol molecules, which are the active ingredient in alcoholic beverages. Ethanol is similar in structure to ethane, which we discussed earlier in this video. Sugar alcohols contain hydroxyl groups and are widely used as sugar substitutes. The suffix -ol usually indicates the presence of hydroxyl groups. Sugar alcohols are also called polyols because they contain multiple hydroxyl groups. Examples of sugar alcohols include sorbitol, xylitol, maltitol, and mannitol. Cetyl alcohol is used as a moisturizer and emulsifier in various cosmetic products. Next, let's take a look at the carboxyl group. As this molecular model shows, the carboxyl group consists of a carbon atom, singly bonded to a hydroxyl group, and doubly bonded to an oxygen atom. Organic chemicals that contain the carboxyl group typically have acidic properties. They are used as flavoring agents, vitamin supplements, antioxidants, and antimicrobial additives. Examples include citric acid, ascorbic acid, which is vitamin C, tartaric acid, and sorbic acid. Now, the third and final functional group that we'll cover in this video is the amine group. Amines are involved in the creation of amino acids, which are the building blocks of proteins and essential for life. Amines are derived from ammonia, which consists of a nitrogen atom bonded to 3 hydrogen atoms while carrying a pair of lone electrons. When one or more of ammonia's hydrogen atoms are replaced by a substituent or substituents, such as alkanes that have lost a hydrogen atom, the resulting molecule is an amine. An alkane that has lost a hydrogen atom is also called an alkyl. The amine functional group in this example simply consists of a nitrogen atom singly bonded to two hydrogen atoms. The unpaired electron in nitrogen's outer shell is available to bond to an alkyl or other substituent. Ethanolamines are the most prevalent form of commercially produced amines. Amines that are bonded to a single ethanol substituent are called monoethanolamines, or MEA. Amines with two ethanol substituents are called diethanolamines, or DEA. And, as you've probably surmised, amines that contain three ethanol substituents are called triethanolamines, or TEA. In personal care applications, ethanolamines serve as foaming agents, emulsifiers, and pH elevators. Amine compounds used for pharmaceutical applications include morphine, OxyContin, and codeine, just to name a few. These amines serve as pain relievers and cough suppressants. Another common amine is monosodium glutamate, or MSG, which is used as a flavor enhancer in foods. So I hope you were able to glean something useful from this video. Thanks for your attention, and I look forward to seeing you in the next video. Have a great day, and remember, knowledge is your edge.